Good morning, everyone. Thank you for attending and for watching my presentation. My name is Mobina Zibandehpur and I am from KN2C University of Technology. Today, I will present our work titled Multimodal Classification of Sense of Direction in Healthy Individuals using Trajectory and Head Motion during a walking-based spatial task. Navigation and wayfinding are among the most fundamental everyone human skills. Navigation refers to ability to determine one's position, plan a route, and move effectively within an environment. It is a vital skill that plays an important role in interacting with the surrounding and successfully carrying out daily activities. A well-developed sense of direction strengthens this ability by enabling individuals to orient themselves more intuitively and make better spatial decisions. In this study, three types of test materials were used. First, human motion capture system data were collected to record participants' head movements using an IMU-based motion capture system with a sampling period of 3 milliseconds. Second, video data were recorded using a webcam camera at 13 frames per second. While participants performed the walking-based spatial tasks, finally, questionnaires were used, including the mini-mental examination tests, to evaluate participants' cognitive level, and also the sense of direction questionnaire to assess participants' self-oriented navigation ability. The test environment was a compact 3 by 2.4 meter space containing 9 squares equipped with LED lights. These lights were programmed to indicate the specific paths that participants needed to follow. A camera was mounted 2.5 meters above the ground to record participants' movements. Throughout the task, in this task, participants were instructed to follow a series of illuminated targets in predefined order, requiring them to continuously adjust their orientation and movements. Data collection was conducted on 35 participants with an average age of 23.4 years. The Corsi walking task was performed in 4 states, and video recording together with motion sensor signals were collected for all participants. Participant movements were recorded using an overhead camera, allowing us to extract their walking trajectory within the test area. The raw paths were then processed and smoothed to obtain the final trajectory patterns. At the same time, motion sensors were attached to the head and trunk of each participant. These sensors captured head motion signals, including various angular movements during the tasks. The recorded signals were later used to analyze head movements patterns as participants navigated through the environment. In this study, we extracted two main categories of movement features to characterize participants' navigation behavior. Trajectory features captured how individuals moved through space, including basic path properties, path dynamics, stop behavior, movement smoothness, curvature, path complexity, and etc. In parallel, head motion features describe the temporal and frequency structure of head rotation, covering statistical measures, amplitude and energy, spectral power, differentiate angles, Fourier components, and nonlinear descriptors. Together, these feature sets provided a comprehensive representation of both whole body movement patterns and head motion dynamics during the navigation task. In this analysis, we examined the correlation between movement features and the sense of direction score across the 4 Walking Corsi trials. Most features appeared only in 1 or 2 trials, indicating that sense of direction related behaviors vary with task contexts. The strongest and most consistent associations were observed in frequency domain head motion features from the internal-external rotation axis, particularly mean frequency and spectral centroid, which reached correlation of 0.46. When averaging correlation across trials, these spectral features ranked highest, suggesting that the temporal dynamics of head rotations during walking are key indicators of sense of direction. The table summarizes the performance of several models in predicting sense of direction score across the 4 Walking Corsi trials. The accuracy averaged 0.75 and 0.77 weighted with soft voting method of ensemble learning, reflecting moderate classification strength. The best performance occurred in trial 2, where an SVM model achieved an accuracy and F1 score of 0.86. Trial 4 also reached an accuracy of 0.86 using gradient boosting, driven preliminary by its high specificity of 0.93. In contrast, Trial 1 showed the weakest result, with notably lower sensitivity and F1 score. The findings demonstrate that model performance differs substantially across trials, suggesting that the predictive level of movement-based features changes depending on the task states. Thank you very much for your attention. If you have any question, I would be happy to answer them. You can also contact us through the email address provided on this slide. Thank you.